All right, let's work on solving some equations that are polynomials or polynomial like. Okay. And we can use the same types of methods, the same approaches that we used with quadratic equations for these. Okay. If I have a polynomial and it factors, that is always going to be my shortest path to my solution set. Maybe I have x to the fourth plus 3x squared minus 4 equals 0. If I can find two numbers that multiply to be -4 and add to be +3, I know this polynomial is going to factor. Okay. The nice thing is if I have a 1 in front of the x to the fourth term, then I can go straight to it. Okay. Now instead of having x and x here for my first terms, this is what I'm going to have there. Okay, that's going to be my power of x. So I'll have x squared and x squared. The two numbers that multiply to be -4 and add to be +3 are +4 and -1. Now from here, personally, if any of these factor more, I like to go ahead and break them down. A plus sign in between the squares isn't going to factor or break down anymore. Okay, but x squared minus 1, the difference of squares, I can break it down to x plus 1 and x minus 1. Okay. Once I have a product of a bunch of things equal to 0, I can set each of those factors equal to 0, and I can solve for x. Okay. I'm going to go right to left here. These will be 1- to 2-step problems if you have a linear equation there. Okay. And x squared plus 4 and x squared in the problem, I know there are going to be two solutions. Okay. We've already decided that it doesn't factor. I could use the quadratic formula, but if I only have x squareds and numbers, shortest path is to separate them and use square roots. Okay. Don't forget that if I put the square root into the problem myself, I have to put plus or minus there as well. Next, I'm going to simplify that radical if it does. The negative comes out as an I, and the square root of 4 is equal to 2. When I'm dealing with a polynomial, and a polynomial is where my powers of x are all whole number values. Okay, if I have a polynomial of degree 4, I'm going to be looking for a total of 4 solutions to my equation. Okay, positive 2i is one of them. Negative 2i is a second one. -1 is a third, and positive 1 is a fourth. I have 1, 2, 3, 4 solutions. It's always a good idea to do a quick count. Make sure you have them all before you go on. Okay, but factoring is going to be my shortest path. Okay, if you're not sure what I did there, you don't like what I did there, then set it up as a grouping problem. The two factors of -4 that add to be +3 are +4 and -1. Okay, so I can regroup my middle term. Instead of having 3x squareds, I have +4x squareds minus 1x squared. And then I can pull out the greatest common factor and do it again. Okay. And I'll get to here after 2 steps. So I'll get to here. Okay. This method, this idea will work even if I have even if it's not a polynomial, but if I have the right pattern. Okay, the right pattern back when we were factoring way back in chapter R somewhere. Usually if the first exponent or the outside exponents are double the middle exponent. Okay, if I take 3/2 times 2, I get 3. Okay, up here we had 4 and 2. We know how to do it with a 2 and a 1. Okay, but it can be 3 and half of 3 here. Okay. We can get the thing factored, assuming there are two numbers that multiply to be -4 and add to be 3, and it's the same two numbers we had above. Okay. Again, the power of x that goes here is the power of x that's right here. Okay. If our pattern is not, if this is a 3 and that's a 2, we can't do this. Okay, it's not going to work. If this one is double that one, we've got the right pattern that assuming these factors exist, then we'll be able to get it factored. Okay, this says 3/2 both times. Okay. From here, we can set each factor equal to 0 and solve the equation for x. Okay. When our exponents are fractions, okay, don't forget that that means the bottom of the fraction, that number, that's the root that we're dealing with. Okay, the top number in our fraction is the power. Okay, it's the exponent, it means we're cubing something. If it helps you to put the radical into the problem at this point, go ahead and rewrite it as the square root of x cubed. Okay. Earlier in this section, we solved equations that had square roots in them. Okay, first, we got the square root by itself on one side of the equal sign. Okay, then we raised both sides to the power of 2. We squared both sides. Okay, squaring a square root makes it go away and just gives you the stuff underneath. So this says x cubed equals 16. All right, if x cubed is equal to 16, that means x is going to be the cube root of 16, which is 2 times the cube root of 2 if we take the time to simplify it. Now we're not done yet, but we're going to go ahead and follow this path down the same way. This is the the square root of x to the third is equal to 1. Okay. Next, I'm going to square both sides to make the radical go away, and that says x cubed equals 1. If x cubed equals 1, then I can take the cube root of each side, and the cube root of 1 is also equal to 1. Okay. Now, because we squared both sides of the equation here in this step, okay, we're not guaranteed that either of these solutions are really solutions to this equation that we were asked to solve at the beginning. Okay, so that means we have to check them to find out if they work. Okay, I'm going to leave cube root of 16 instead of in this form when I plug it in, because if I cube the cube root of 16, I'm just going to get 16. Okay. So this says 16 plus 3 times here again, cubing the cube root gives me 16 to the 1/2, which would be 4. This says 16 plus 12 minus 4 equals 0. Okay, that is not a true statement, which means cube root of 16 is not really a solution to this equation here. If I plug in 1, I like dealing with 1 because 1 cubed is 1 and 1 to any power is 1. So this says 1 plus 3 times 1 minus 4 equals 0, or 4 minus 4 equals 0. Okay. That is a true statement, which means 1 is my only solution here. When I'm factoring, as long as the pattern is so that this first exponent is 2 times the middle exponent. 3 halves times 2 is 3. 2 times 2 is 4. We can get the polynomial factored and broken down, assuming that the factors, there are 2 factors of this number that add to be here. Once we have the polynomial or the polynomial-like thing, this is not really a polynomial, factored, we can set the factors equal to 0, solve for x. If in the process of solving you have to square both sides of the equation, then you have to go check and see if those solutions work or if they don't. Your author shows you an alternative path, a substitution. Some people use the word disguise on there, but if you understand how to use a substitution, feel free to do that as long as you can do it correctly. But a lot of students at this level get more confused by that than just trying to set up a grouping problem and get the polynomial or polynomial-like thing factored. Give me a shout if you need help with something.